Welcome to A7. Here we are, week 8, okay, electromagnetic radiation. Okay, so we studied waves last week, okay, but electromagnetic radiation is a type of wave energy which has some pretty amazing properties. Right? So by definition, it is wave energy traveling at 3 times 10 to the 8 meters per second. All right? So if you think about that, that's 300 million meters per second, which for us Americans, this may be a better way to relate to it, 186,000 miles, not per hour, but per second. So it is really, really fast. Okay? So if you were to take our Earth, okay, in your hands here, model it down, it's about 5.5 times around the Earth each second. So it is really fast. Next, it has the ability to travel through empty space. Okay, that's key. Okay, so light is one portion of it, visible light. Okay, so sometimes we'll just say, instead of a speed of electromagnetic radiation, we'll say speed of light. Okay, but it's really fast. And the great thing is, it delivers us our energy. For life to exist on Earth, we have to have energy. Okay, so if you think about that, we get that energy from the sun. Sun gives off light energy, but it also gives off other forms of electromagnetic radiation also. Right? But if you think about it, the sun's giving off these waves of energy, and they're going off in all these different directions. Okay, so in actuality, Mercury's getting hit by sun, Venus, okay, all around. Most of the energy delivered from the sun doesn't even hit us. Okay? That which does travels through space, empty space. Okay, how many miles is it? All right, that's the first question. It is about 93 million miles. Okay, so how long does that take? Well, it takes about 8 minutes. Okay, so if the sun was to somehow go out right now, we would have 8 more minutes before we would notice it. Okay, but that's traveling at 186,000 miles per second. You guys can do the math on that if you'd like to. Now, sunlight hits the Earth. Okay, some of it is just reflected back off the atmosphere, off the clouds. Some of it's absorbed by the clouds. Okay, and then of course some gets to the Earth. Okay, but only about 1% of that energy that we actually get, say none of that stuff, but just about 1% of what we get, we capture. Okay, and of course, our friend the plants do that in photosynthesis. So they can take that light energy, okay, from the sun, okay, and we can change that into sugars. I'll put glucose here. That's a type of sugar. All right. Okay, so that's what drives life on Earth. Okay, so that's kind of a good general overview of what happens there. All right, now light or electromagnetic radiation acts like a wave. It acts like a transverse wave. If you recall, transverse wave, the wave is going this direction here. The actual particles would move up and down. Okay, if it does travel through particles, okay, empty space, it just acts like a wave. Now you can take this electromagnetic radiation and break it down into 6 major areas. Okay? We start here with radio. Okay, then we move into infrared or heat, then visible, okay, our friend Roy G. Bev here in the middle, okay, ultraviolet, X, and gamma. Okay, so they are all related, okay, because they are electromagnetic radiation. Okay, they have that speed and they deliver energy. Where they differ is in their wavelengths and their frequency. Okay, so if you start on this end of the spectrum over here with radio waves have very long wavelengths, okay, and pretty low frequencies. And as you go across here, you get all the way over here to gamma rays, where we're going to have really, really short wavelengths and high frequencies. Okay? The amount of energy a wave has depends on the frequency. Okay? They go hand in hand. So if something has a high frequency, it's got high energy. Okay? Something has low frequency, it has low energy. So, as I said before, the sun gives off all those forms of energy. Okay? Luckily for us, we have a nice atmosphere around us. Okay? And that atmosphere blocks most of these, quote, damaging forms of radiation. Okay? So gamma rays, which can be lethal. Okay? X-rays, which of course can penetrate your body. Okay? They get picked up by bones. That's why they're good for X-rays, for seeing broken bones and so forth. And then you probably know ultraviolet rays can cause sunburns. Okay, but these are mostly blocked by our atmosphere, which is a great thing for us. Okay? Of course, we pick up visible light. Okay, so visible is kind of just right for humans. We've kind of probably evolved that way, where it's enough energy that we can pick it up, photosynthesis, but not so much energy that it destroys our tissues and cells. And then we have heat over here, and then radio waves, which is good for communication. All right? So, this is also tied together by this formula. Velocity equals wavelength times frequency. So we told you before the speed is 3 times 10 to the 8th power. Okay, so you probably know that's the same as 3, 1, 2, 1, 2, 3, 1, 2, 3. Okay, so 8 zeros after that, meters per second. So that's 300 million meters per second. Okay, that's going to equal, okay, whatever wavelength it is times frequency. Okay, so if I was a radio wave, it would be a long wavelength and a low frequency, and of course gamma rays, short wavelength, high frequency. Okay, but that means these two quantities here are, we say, inversely related. Okay, so if we go from, let's say, radio waves to ultraviolet, okay, the wavelength is going down, which means the frequency has to compensate and go up. So as one goes down, the other goes up. Because, as I said, this number is going to stay the same. Okay, so if velocity stays that number, if this number goes down, this one has to go up. Okay? So they're related that way. Let's finish off with some major functions of each of these forms of electromagnetic radiations, how they're useful for us. Of course, we can start here with radio waves. Radio waves, of course, are great for communication. Communicate. Okay, so radio. And of course, some of you guys have phones, cell phones. They use radio waves. Infrared is sometimes known as heat radiation, and of course that keeps us warm. Okay. Visible rays, of course, we owe our life to that. Roy G. Biv, the part of the spectrum. Okay, so that's what we can see with. Okay, we're really visible creatures as humans. Okay, so we pick up these different wavelengths of light. We can make images. Of course, I already talked about plants and photosynthesis. So this gives us life. Ultraviolet also delivers a lot of energy to us. It can, of course, be harmful, causes sunburns. Okay? But it also can be used in medicine and to sterilize wounds and so forth, sterilize food. X-rays, of course, for images. You can detect, dentistry. You can see if what's going on with your teeth, with bones. And then gamma rays, that's kind of lethal radiation given off in like atomic bombs, nuclear reactors. They give off radiation by nuclear decay. There can be some just naturally by lightning, but again, that's the type of, when you talk about radiation sickness, okay, that's what they're talking about, gamma rays mostly. Some